Dear student, today we'll start the ionization of acids and bases. Then after that, we'll see the dissociation constant of weak acids and weak base. And next point is the Ostwald dilution law. First one, these are the 3 points. First, one by one, ionization of acids and bases. We know that previous lecture we have seen the degree of dissociation, then what is meant by the acids and the bases according to different scientists. Now let us see the ionization of acids and the bases. Ionization, ionization is the formation of ions. And this dissociation means what? That means separation of ions. Now here the how to ionize the acids and the bases. Ionization of acid and ionization of base. We know this that acids and bases are classified as one is the strong acid and the second one is the weak acid. These are the two types are the classified as strong acid and weak acid. Now this strong acid or bases, weak acid or the bases. There are the two types or two classification. Now this strong acid or the base, weak acid or the base. For example, strong acid HCl is the strong acid, H2SO4 is the strong acid, HNO3 is the strong acid because whose dissociation is completely, almost completely. Therefore, this HCl, H2SO4 or the HNO3 are the strong acids. Strong base is NaOH, then KOH is the strong bases, example of strong bases. Now HCl is the one acid, it gives the or it dissociates to formation of H plus and the Cl minus ions. HCl is a strong acid which dissociate to formation of H plus and the Cl minus ions. That is in aqueous form. Means that formation completely dissociated, completely ionized. Therefore, HCl which in aqueous dissolve in water to produce the H plus and the Cl minus ions. Another base, sodium hydroxide, which dissociates completely and to formation of Na plus and the OH minus ions. Completely dissociated, completely ionized. Now this is about the strong acid and the strong base. Another is the weak acid or the weak base. Another type, weak acid and the weak base or the weak base. Now example for weak acid, now see here the CS3COOH, that is acetic acid, it dissociates to formation of CS3COO minus and the H plus ions. Another base, that is the ammonium hydroxide is the weak base. It dissociates to formation of the ammonium ions and the hydroxyl ions. Now this acetic acid and the ammonium hydroxide are the weak acids and the bases, because this weak acid and the weak base are feebly ionized, slightly ionized, partially ionized, and that's why which gives the acetate ions and the H plus ions, ammonium ions and the OH minus ion. This is the dissociation of the strong acid, strong base, weak acid and the weak base. Now important point is that the strong acid and the strong base are completely ionized. Therefore, the dissociation study is the weak acid or the weak base, because that strong acid and strong base is completely dissociated, almost completely ionized, and that's why we have to study the dissociation study of the weak acid or the weak base. Then another point will knowing the how to determine the dissociation constant of weak acid and the weak base. We have to knowing the dissociation constant of the weak acid and the weak base. Now let us see. Suppose the HA is the one weak acid. Then it dissociate to formation of the H plus and the A minus ion, that is in aqueous one. This HA is the weak acid which dissociate and to formation of the less number of or slightly the number of dissociation of H plus and the A minus ions. And if you determine the dissociation constant, dissociation, that means what? That means separation. Here the one is the acid which separate the ions H plus and the minus A minus ions. But you have to determine the dissociation constant. According to the law of mass action, that law of mass action is in a previous year, 11th year, we have to see already. Then if you apply this law of mass action in this reaction, the equilibrium constant or equilibrium, this K is equal to the concentration of H plus into concentration of A minus divided by concentration of the HA. This is the molar concentration square bracket which indicate the molar concentration. This K is nothing but the equilibrium constant. Now here in this reaction, this K is equal to the H plus ions into A minus ions divided by, that is the HA, means the molar concentration, that is HA is the very small. That's why this K into, that is constant, very small. K into that HA constant, that is another constant K dash, is equal to the H plus, or only keep as it is the HA. Now this is for K. Which K? That HA is the acid. That's why Ka is the dissociation constant for weak acid. If you knowing the molar concentration of H plus, molar concentration of A minus and molar concentration of HA, then easily we can calculate the dissociation constant for weak acid, and that is to determine the dissociation constant of weak acid. Similarly, if you take the base, Which base? That weak base, dissociation of weak base. Now let us see here, the BOH is the one substance or which is the weak base in a aqueous form or dissolved in water to produce the B plus and the OH minus ions. That is the B plus and the OH minus ion. That is this is for the weak base. Weak base. BOH is the weak base dissolved in water to produce the B plus and the OH minus ions. If you determine the dissolution constant of weak base, then how can you calculate the dissolution constant of weak base? Similar this one Ka or the weak acid, then applying the law of mass action, the equilibrium K constant, K equal to the molar concentration of B plus into molar concentration of OH minus ions divided by molar concentration of BOH. Now this is for the equilibrium for which the weak base. Kb is the equilibrium constant for weak base. Means Kb equal to the molar concentration, is a square bracket which indicates the molar concentration, means B plus into molar concentration of OH minus ions divided by BOH. Now, so this is suppose the equation number 1 and the equation number 2. Now, these are the equation for which the dissociation constant of weak acid and the weak base. Then the third one or third point, that is a very important examination point of view. So many asked in that exam for at least 2 marks. That is very important in the point of examination point of view. Now let us see the Ostwald dilution law. Ostwald dilution law. Ostwald dilution law. It is also called as the Ostwald dilution formula. Now in 1888 proposed that law, formulated this law, Ostwald dilution law. This Ostwald dilution law is an expression, the relationship between the degree of dissociation, then a dissociation constant and the concentration of the solution of the electrolyte. These are the 3 terms. Means the Ostwald dilution law, which state that, or formula which state that that is an expression which a relationship between the degree of dissociation, then a dissociation constant and the concentration of the electrolyte. These are called the Ostwald dilution law or the formula. Now, how to explain the Ostwald dilution law or the formula for weak acid? Now, for the weak acid, now in your annual exam, what type of question is asked in annual exam? Question is that what is the Ostwald dilution law or the formula, or what is the, or derive the expression for Ostwald dilution law or formula for weak acid. Derive the expression for Ostwald dilution law for weak base, and that is a very important. Out of this one, whether the weak acid or the weak base, that one is asked in annual exam, and that's why you removes 2 points, weak acid and the weak base. First, one by one, there are the expression for the that weak acid, osmolalation for weak acid. Now, for weak acid, consider the HA. Consider the HA is the weak acid dissolved in V liter of the solution. V liter or decimeter cube of the solution, and alpha be the degree of dissociation. Now first you have to consider now, let us consider the HA is a substance, which substance of weak acid dissolved in water, and in 1 mole of that 1 mole of that substance, this HA dissolved in water to produce the dissolve in V liter of the solution, and alpha be the degree of dissociation. Now the consideration. Now therefore, the dissociation of that electrolyte, which electrolyte? Weak electrolyte. Weak electrolyte? That is the acid. Means HA is the 1 mole which dissociate to formation of H plus and the A minus. This is the 1 mole dissociate, formation of H plus and the A minus ions dissolving V liter of the solution, and the alpha be the degree of dissociation. We have to determine that for weak acid, Ostwald dilution law for or formula for weak acid. Now HA is the 1 mole, means initial mole A is the 1, and dissociate, that means 0 and 0 initially. Then at equilibrium condition, means out of this 1 mole, some amount of substance will be dissociated. Some means how much? The small fraction. Small fraction, that means how much? Alpha. Therefore, 1 minus alpha is the at equilibrium for HA. Alpha is the degree of dissociation of that H plus, and same to the A minus also. Means at equilibrium condition, the value of HA is the 1 minus alpha. This much amount of alpha will be dissociated. Alpha is the H plus and alpha is the A minus. Same values. But at equilibrium condition, the concentration per liter means 1 minus alpha divided by V, then alpha divided by V, and alpha divided by V, because this volume dissolve in V liter of the solution. That's why 1 minus alpha is the amount of that substance dissociated at equilibrium divided by V. Alpha divided by V, alpha divided by V. Therefore, the molar concentration of HA is equal to 1 minus alpha upon V. Then alpha, or the concentration of molar concentration of H plus, equal to alpha upon V, and molar concentration of the A minus is equal to alpha upon V. Now these are the values. Molar concentration HA 1 minus alpha upon V, molar concentration of H plus equal to alpha upon V, and molar concentration of A minus equal to alpha upon V. Now let us see. Now this is one equation or the reaction. But applying the law of mass action, the equilibrium, you have to calculate the equilibrium constant. The applying the law of mass action, this that reaction is equal to K equal to this concentration of H plus into concentration of A minus divided by the molar concentration of HA. This is for the weak acid, and that's why Ka is equal to the molar concentration of H plus into molar concentration of A minus divided by molar concentration of HA. Now, the molar concentration of HA, molar concentration of H plus and A minus, values, these values, molar concentration of HA equal to 1 minus alpha upon V, then H plus equal to alpha upon V, A minus equal to alpha upon V. Putting the values in this equation. Suppose this is equation number 1. Put the values, means putting the values of HA, H plus and A minus. Now that values are, see here. Therefore, put the value equal to H plus, value of H plus is the alpha upon V, into A minus is the alpha upon V, and then divided by the HA is the 1 minus alpha upon V. That is the value. Then E is equal to the alpha square upon V square, then into V upon 1 minus alpha. Then E is equal to this alpha into V, alpha square into V upon V square upon 1 minus alpha. This V and then 1V get cancelled, remaining will be the alpha square. Is alpha square upon the V upon 1 minus alpha, or equal to alpha square C upon 1 minus alpha, because 1 upon V is nothing but the concentration. Therefore, instead of that 1 upon V, put the value C. Alpha square is C upon 1 minus alpha, and you know that Ka equal to the alpha square C, and alpha square C, because 1 minus alpha is very small, therefore that can be equal to 1, means alpha Ka equal to alpha square C, and this is one equation for the Ostwald dilution law for weak acid. If you knowing the alpha, degree of dissociation, concentration is known, therefore you have to easily calculate the Ka, dissociation constant of weak base. Now this is about the Ostwald dilution law or formula for the weak acid. And next lecture on terms, ionization of acids and base, dissociation of strong acid and weak base, then Ostwald dilution law for weak acid. These are 3 points. Understood point? 3 points. Okay. Then next lecture we will see the Ostwald dilution law for weak base and the numericals on this Ostwald dilution law. Okay, students. Is any difficulty? No? Right.